All right, today we are going over simplifying negative and zero exponents. So if you want to pause and write this down as your objective, go ahead and do so now. All right. All right, so the first thing we have here is use the examples to the right to explore the properties of negative exponents and zero. First, subtract the exponents to simplify the expression, then write out the expanded form of each one. So 2 minus 5 would be 2 minus 5 would be negative 3, so it'd be b to the negative 3 power. So if we did this in expanded form, you have b times b over b times b times b times b times b 5 times. So you could cross out these two. And you realize you have none on the top. So you could write a 1 for your top exponent. And then 1, 2, 3. So b to the third. So b to the negative 3 and 1 times b to the third here are the same thing. If the exponent is negative, it just means the base is in the bottom. Here, you would have, if you subtract, following our rules from yesterday, you get 3 to the 0 power. If you did that over, you would get 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. And we could cross out. And we could get, when we cross out, we get 1 over 1, or just 1. So anything to the 0 power simplifies to 1. So here, a to the negative power equals equals 1 over a to x, whatever the negative x. When an exponent is negative, write the reciprocal. So the reciprocal is just a fancy way of saying flipping it. If remember from multiplying fractions, and when we flip it, we put it over 1 when we have a whole number here. So of the base, and the exponent becomes positive. So you'll see if we have a fraction that will actually flip the whole fraction. But when we have a whole number, we just put it 1 over. And then a to the 0 power is 1. Any base raised to the power of 0 is 1. So we're going to start with our next one. So h to the negative 6 is going to be 1 over h to the 6. When we have whole numbers or just a variable, we put it over 1. Because technically this is h to the first, h over 1 to negative 6. So you just flip that and get 1 over h and change that exponent to positive. Here we have negative n, or n to the negative 3 power. So it'd be 1 over n to the third. And then here we have kind of a combination. So go ahead and pause, try and do this one on your own. And then you can, so you would multiply these two because it's a power to a power. So we learned yesterday we multiply that. So negative 4 times 2 it would be b to the negative 8. And then you would simplify it by doing b. So 1 over b to the positive 8. Now this says simplify the expression. Don't leave any exponents in your answer. So the first step is we're going to keep the exponents. We're going to do what we've done before, and we're going to do 1 over 8 squared. Now you guys can solve 8 squared, and you just do 1 over 64. So here, you could solve 10 to the third and then 10 to the fourth and then divide. Or you could go 3 minus 4 is negative 1. And then so 10 to the negative 1 power is 1 over 10 to the first power, which equals 1 over 10. Anything to the first power is just the number itself. So that would be the steps on that. So go ahead and pause and try and solve this one. You can use your calculator to solve the 2 to the 4th power. And then go ahead and pause. Remember that 8 minus 8 is 0. And then what would be 5 to the 0 power? I want to see your actual, do not leave any exponents in your answer. So I'm going to be checking to see if you left this with the exponent or if you finished the problem on your own. All right, this one is you have to apply, you have a whole expression here and we have to apply multiple different steps to the exponents. So the first step is you follow PEMDAS. So the exponent to the exponent here. So that would be, keep your a fourth here, just bring it down, times a to the negative 10th power here. So then when you have those two, you add, so 4 plus negative 10, which would be negative 6. And then a to the negative 6 would be 1 over a to the 6th. And I'm going to use a capital A here just so it's a little bit clearer to see, but 1 over a to the 6th. All right, now we have m. So remember, when you have it in parentheses like that, you distribute this to both. So you'd have m to the 9th power times n to the negative 9 power. Sorry, not negative 3 power. Because you got 3 times 3 here. Negative 9. So you would flip it. So you would get m times 1 times n to the 9th, or m to the 9th times 1 over n to the 9. And then your final answer here would be m to the 9th over n to the 9th. Like that. And that would be your final answer. Here is your next step. So the first thing you have to do is do I want you guys to pause and try and figure this one out on your own. Go ahead and add those two first, and then do your subtraction and see what you get for your final answer. And we have another one here. Break it down. You're going to add here. You're going to multiply here. And then subtract to see what you get for your final answer. I want to see you guys trying these problems on your own. Same thing with this one. I want to see you guys trying them on your own. You're going to multiply it out. So it'll be, and remember you got to distribute this too because everything is in the parentheses here. So it'll be j to the negative 2 times k to the negative 4. And then everything's going to get flipped. So it'll be 1 j to the 2nd over k to the 4th. All right. Label the sentence, label the statement true or false. Be sure to show your thinking. So we got to add these two together here. And z would then equal negative 5. And then if we add these two together, z equals positive 5. So this one would not be true. This one would be false. Those two do not equal each other. So again, pause and try and figure this one out, and then tell me, then check your answer. 8 minus negative 3 is going to, or negative 8 minus negative 3 is going to be A is equal to negative 11. And then 6, or negative 17 plus negative 6 would be A is equal to negative 23. So this one would not be equal. So this one would be false as well. Oh, sorry, this one's minus, or, sorry, I need you guys to double check that. This one is A is equal to negative, or A is raised to the power of negative 11. This is minus, so that negative 17 becomes plus 6, and this would also be A is equal to negative 11. So this one would be true. So I will have a clear vision of who is looking at the video and who is not based on this and whether or not you should say that's true or false. All right, go ahead and try this one on your own. Remember, when you're raising a power to a power, you're multiplying. Here you're subtracting. And then simplify Olga's expression and see if she made A work. All right, you guys have a great day, and I will see you guys shortly. Bye.